Welcome to SV Union High School and Junior College. Today we are going to discuss about the multiprogramming. So we'll see what is a multiprogramming. As the name suggests, multi, that is a multiple program we can perform at the same time. It is called as a multiprogramming. It is a very important concept of operating system. Sharing the processor when two or more programs reside in memory at the same time is referred as multiprogramming. So this is a definition about the multiprogramming. When we going to perform more than one program, that time it requires some memory in a main memory. Okay, so it is called as a multiprogramming. Multiprogramming assumes a single shared processor. Multiprogramming increases CPU utilization by organizing jobs so that the CPU has one to execute. As the number of the jobs are there, but at a time only one program is performed by the CPU. An operating system does the following activities related to multiprogramming. First, the operating system keeps several jobs in a memory at a time. Okay, as the number of the jobs we are going to perform, so there are the number of the jobs in a memory, but only one job is going to perform by the CPU. This set of jobs is a subset of the job kept in the job pool. The operating system picks and begins to execute one of the jobs in a memory. So whatever the jobs are present in there, the job pool, one by one job is taken by the CPU and is going to execute. Multi-programming operating system monitor the state of all active programs and system resources using memory management program to ensure that the CPU is never idle unless there are no jobs to process. Okay, the CPU is going to not be idle because of whatever the multi-programming concept. Number of the jobs come one by one and is going to perform. There are some advantages and disadvantages of multiple programming. First, advantages: high and efficient CPU utilization, as there are number of the jobs are present, so one by one come and execute, so there is a more or the efficient utilization of CPU takes place. Users feel that many programs are allotted CPU almost simultaneously. So user cannot differentiate that one programs come and execute. We feel that all the programs are executing simultaneously. So those are executing very fastly. Disadvantages: CPU scheduling is required as the number of the jobs comes, so we have to schedule the timing of the CPU for each and every job. So scheduling is required. Second, to accommodate many jobs in memory, memory management is required. Again, this is the important that we have to perform the memory management as the number of the jobs come, so it requires the memory to memory. To overcome the problem of underutilization of CPU and main memory, the multiprogramming was introduced. The multiprogramming is interleaved execution of multiple jobs by the same computer. So whatever the multiple jobs comes, that are performed by the same computer, as there is only one CPU. Processor unit is there. In multi-programming system, when one program is waiting for input-output transfer, there is another program ready to utilize the CPU. As there are the number of the programs, so one program is executing. Suppose one program is waiting for the input and the output, then the next program, which is ready with all the resources, can undergo the execution by the CPU. So it is possible for several jobs to share the time of the CPU. But it is important to note that multiprogramming is not defined to be the execution of the jobs at the same instance of the time. It is not going to execute all the programs same time. One by one program comes. When those programs ready with the resources that come under the execution of the CPU. Rather, it does mean that there are a number of jobs available to the CPU that is placed in a main memory. All these jobs are present in a main memory only, and a portion of one is executive then a segment of another, and so on. A simple process of multiprogramming is shown in figure. We will see. Now see in a diagram. There is a secondary storage devices, then main memory. It is divided as supervisor, job A, job B, job C, and the CPU. Okay. Then job B is in the execution. As in this diagram, job A is writing data on the disk, that is using the input and the output operation. Then job B is under the execution and job C is with all the resources, but it is waiting, that is getting the timing of the CPU, that is the CPU concentration. As shown in figure, at the particular situation, job A is not utilizing the CPU timing because it is busy in input output operations. As it's want to write something, so it requires the input. So it is waiting over there. Hence, the CPU becomes busy to execute the job B. Okay, so in this situation, job A is waiting for the input output operation. So job B is there under the execution by the CPU. Another job C is waiting for the CPU for getting its execution time. So in this state, the CPU will never be idle and utilize maximum of its time. So it is not idle, means it is not only sitting without executing any job, because one by one job comes and it goes under execution by the CPU. Now we'll see degree of multiprogramming. The number of processes running simultaneously competing for CPU is called degree of multiprogramming. Means as we have seen, multiprogramming means what? Number of the programs are performing, and for each and every program there is a processes are created. So if there are the number of the jobs, then the number of processes are created, and those processes are waiting or competing for taking the time or concentration of the CPU is called as a degree of multiprogramming. The degree of multiprogramming describes the maximum number of processes that a single processor system can accommodate efficiently. Okay, so each and every process should take the concentration of the CPU and goes under the execution. It is done by the processor. The primary factor affecting the degree of multiprogramming is the amount of memory available to be allocated to executing process. So this is about the degree of multiprogramming. Now we discussed very important topic, context switching. As the name suggests, switching, moving from one process to another. In the operating system, there are cases when you have to bring back the process that is in the running state to some other state like ready state or wait or block state. That we know that for the process there are the different states are there. Either it is in a ready state or wait or block. If the particular process is under the ready state and it goes to the running state, and from running state because of some particular reason, either requirement of input output resources or a higher priority process comes, because of any reason that process has to come from running to any other state, either wait or block state. Okay, so it is the have to move again back to the situation where it stops its execution. So this situation happens says in the life cycle of process. If the running process wants to perform some input output operation, then you have to remove the process from the running state and then put the process in the queue of input and the output. Means if some process is running and it requires some input output operation, that time that process will be removed from running state and it will come to the resources queue, that is requirement of input and output. Sometimes the process might be using a round robin scheduling algorithm where after every fixed time quantum the process has to come back to the ready state from the running state. So in this algorithm what happens is, for execution of process particular fixed time is provided, and after that time is getting over, then process has to come back. So these processes switching are done with the help of context switching. Okay, so context switching means what? As Only one process can be activated at a time. Each process thinks that its own all memory. Context switching. See in a diagram. First, user program is there. Then process 1, process 2 and process n. Now, moving from process 1 to process 2, there is particular little timing is wasted or gets, it is called as a context switching. Moving from one process to another process, whatever the time is required, it is called as a context switching. Now, context switching, stopping one process and restarting another process. Sequence of action. Operating system takes control through interrupt. Okay, if there is an interrupt of one process because of any other reason, then the control is takes place by the operating system. Save old context in the process PCB. Reload new context from the new process PCB. Okay, if one particular process is executing and because of some reason interruption takes place of execution of that process, then the new process getting the control of the CPU. Return control to the application program. So this is the context switching. Now we'll discuss about the process steps. There are the different states of the process. In a multitasking computer system, processes may occupy a variety of states. Operating system defines three basic process states as given below. First, running, second, ready, and third, block. So here, running, if it is request or the process required for the input output, then that process can move from running to the block state. If that input and output resources requirement is complete, then from block to it move to ready state. And when it is takes the control by the CPU, then it moves from ready state to running. If time out, if process is executing, that is under the running, and time out, again it come from running to the ready state. And then when the gets the control of the CPU, then it comes from ready to the running state. So these are the states of processes. A process move into running state when it is chosen for the execution. The process's instructions are executed by one of the CPU or cores of the system. There is at most one running process per CPU. Obviously, at or completion of one process, then come the second process. This takes place continuously. So only at least one process should be there under the execution. A process which is executing is termed as running process. In multiprocessing, there will be many running processes and operating system will have to keep the track of all them. Second, ready. A ready or waiting process has been loaded into main memory and is awaiting execution on a CPU. When the process is the ready or waiting state, then it is with all the resources which are required for execution and it is come to the in main memory. It waiting over there or it is ready to execute and waiting till it takes the concentration or control of the CPU. There may be many ready processes at any one point of the system's execution. For example, in a one processor system, only one process can be executing at any one time and all other concurrently executing processes will be waiting for execution. A process which is not waiting for any external event such as input-output operation is said to be in a ready state. Means it is having all the input-output resources, then it is in a ready state. And last one, blocked. Process which is waiting for an external event such as input-output operation, it is said to be in a block state. When any process is waiting for the input and output, then it is in a block state. A process transitions to a block state when it cannot carry on without an external change in state or event occurring. For example, a process may block on a call to an input-output device such as a printer if the printer is not available. If this printer is not available, then this process is blocked as the resources are not available. So this is about the states of processes. Here we discussed about the multiprogramming, context switching and the process states. So this is about the concept of multiprogramming in operating system. Thank you.